Okay, so we have an investment here. It costs 1 million kwacha. We've been given some expected cash flows from this investment. In year one, we expect to make a 760,000. In year two, we expect to make 300,000. In year three, we expect to make 250,000. We're given a residual value of 150,000. So after 3 years, this machine, we can sell it for 150,000. Okay. We're given the weighted average cost of capital, which is 10%. Okay, so this is the overall cost of financing. In order to get this investment here, we need to sell shares and sell debt. All right, so our overall cost of financing, okay, to raise the finance through equity or debt is 10%. So they're asking determine if the project is viable using the net present value technique, the internal rate of return technique. Okay, so this is under capital budgeting or investment appraisal. This the essence of the topic is to find out if a certain investment is worthwhile or not. We're just deciding where to put our money in. Okay. Yes. So we're going to use two methods, the net present value technique and the internal rate of return technique. All right. Both of these techniques use the time value of money. Okay. It's going to involve converting money in the future into today's value. So we're going to start with the net present value technique. So first things first, we'll need to make a table. Okay, we have our years. We have the cash flow. We have our discount factor. Mm-hmm. No, you can also show it as a tabulation. Okay. It's not always that you can show it as as a table. The other ways you can show it also. Okay. So we have to get our cash flows. Okay, so we get our cash flows here. Okay, so in year zero, you're going to put negative 1 million because this represents a cash outflow. In year one, you put 760,000. Year two, 300,000. Year three, 250,000. Year four, not year 4. Still, this is year 3. Okay, because we're saying after its useful life, you can sell it for. So this will still be in year 3. Okay, residual value year 3. Okay, if you want, we can even combine. We can add. Okay, we can add them. You just add 150 plus 250,000. Right. Then our discount factor. Okay, we get it from our tables, our present value tables. Remember, the discount factor is 1 plus R, which is the discount rate, to the power negative t. So in this case, our rate is 10%. So it's 1 plus 0.1 to the power negative t, which simplifies to 1.1 to the power negative t. If you're not using the table, this is what you can do. Okay, you just put here 1.1 to the power negative 0, 1.1 to the power negative 1. You're just following the years. Okay, so here in year 2, it will be 1.1 to the power negative 2. Here in year 3, it's going to be 1.1 to the power negative 3. Okay, that's if you're not using the tables. But if you're using the tables, okay, you just go on your table. Okay, the present value table. Okay, you look for your discount rate, 10%. Okay, so let me get the values to put in Excel. Okay, so in year 1, we're just reading from this table, discount factor 0.909. Year 2, 0.826. Year 3, 0.751. Year 4, oh, not, wait. Year 0, it's actually 1. Okay, 0, since it's to the power negative 0. 1.1 to the power negative 0 is 1. So let me move these. Year 0, the discount factor always be 1. Okay, colleagues? It's always going to be 1. Okay, the discount factor is always going to be 1. Okay. And then for the residual value here, it's still year 3, so 0.751. Okay. These are our discount factors. So remember, your present value is just the cash flow multiplied by the discount factor. Cash flow multiplied by discount factor. That's how you get your present value. So you're going to say negative 1 million multiplied by 1. That's negative 1 million. 760,000 multiplied by 0.909. You get that number. 300,000 multiplied by 0.826. You get that. 250,000 multiplied by 0.751. You get that. Okay. We just continue with the process. Yes. Then once you've got your present values, you just total them up. Okay, you just add everything. Okay, negative 1 million plus 690,840 plus this plus that plus this, we get 239,040 kwacha. Okay, 239,040 kwacha. Okay, that is the net present value. So according to the net present value technique, colleagues, it tells us that if your net present value is positive, you accept the project because that can signal gains or profit. Okay, positive net present value, think of it as profit. Okay, so you accept if it's positive. If your net present value is negative, then reject the project because that negative value can represent losses. And then if your net present value is zero, it's more like you're breaking even. Okay, and you still have to reject because you wouldn't want to make an investment just to break even. Okay. Any questions before we go to the internal rate of return? Okay. So the internal rate of return is just basically we're just asking what is our return from this investment? Okay. What is our return from this investment? Okay. So the return will be expressed as a percentage. Okay. Going to be expressed as a percentage. So under the internal rate of return technique, it's just a continuation of the net present value technique. Okay. All that needs to be done here is this. You have to remember this. If your first net present value is positive, increase your discount rate. Okay. If first NPV is positive, increase discount rate. So that the reason why doing this is so that you will get a negative net present value. Okay. Then if the first NPV is negative, decrease discount rate so that you get a positive NPV. Okay. So in this case here, since we have our first NPV is positive, so we need to increase our discount rate. So we can increase our discount rate. So you choose any percentage above 20, okay? Above 10, any percentage, okay? So I'll use 20%, okay? It's up to you to choose, okay? You are not restricted, okay? So I'll use a discount factor of 20 here. Here we use a discount factor at 10%, okay? So we go to our present value table and we get our discount, look for our discount rate, which is 20%. So these are the values we need to get. So 0.833, 0.694. Discount factor in year 0 is 1. In year 1, the discount factor is 0.833. Here 2, 0.694. All of these values I'm getting from the table. Okay. 0.833, 0.694, 0.579. 0.579 and here 0.579. Okay, so we get our present values. Okay, we get our present values. Still, we're multiplying our cash flows by our discount factors. Cash flow multiplied by discount factor. And here, cash flow multiplied by discount factor. Then we do the same process. Okay, so it's still positive. It means we need to increase our discount rate because 20% are still given as a positive one. Okay, so let's increase to 50% then. Okay, we increase to 50%. Maybe 50% will give us a negative value. Okay, so our discount factor, since R is 50%, so here it's the same as 50% is 0.5. So that's, so our discount rate would be 1.5 to the power negative t. Okay. So we get our calculators. So we say 1.5 to the power negative. Let me get some bundles first. Yes, so we're trying 5%, 50%. So 1.5 to the power negative 1, 0.66. So it's automatic multiplying. 760,000 times 0.66. 1.5 to the power negative 2, 0.44. So 300,000 times 0.44. 1.5 to the power negative 3, 0.29. Okay. Then here, also here we still use 0.29 for the residual value. Yes, we get a negative net present value. So once we've got a negative net present value, we can now apply the formula. Remember, the internal rate of return is your lower discount rate plus net present value with a lower discount rate divided by net present value with the lower discount rate minus net present value with the higher discount rate, then the higher discount rate minus the lower discount rate. That is the formula. Typing it out is going to be, yeah, so I'll put it like this. Yes. The lower discount rate plus the net present value with the lower discount rate over net present value with the lower discount rate minus net present value with the higher discount rate. High discount rate minus the lower discount rate. So in this case, our lower discount rate was 10%. The net present value with the lower discount rate is 239,040, right, divided by 239,040 minus the net present value with the higher discount rate is negative 250,400 divided by close brackets the higher discount rate 50% minus lower discount rate 10%. Okay, so we do 239,040 minus negative 250,000. Let's see, what value do we get? 498,440. So 10% plus 239,040 divided by 489,440. It's 40%. Okay, then we divide 239,040 divided by 489,440 gets 0.489. So it's 10% plus 0.489 times 40%. So 0.48 or 488. 0.488 multiplied by 40, what do we get? 19.539. And 5358. If we add that plus 10, 29.53%, 5358%. Okay. So that is our internal rate of return. Okay, this is the return from our project, our investments. So we compare the internal rate of return versus our overall cost of capital, which is 10%. So if your internal rate of return is greater than your cost of capital, or work, accept the project, because it means the return you're getting from the project is greater than the cost you incurred to finance this project. Okay, so in this case, our internal rate of return is greater than the cost of capital, so we accept. If your internal rate of return is less than your cost of capital, you reject, because it means your return from your investment is less than what it costed you to do that investment.